Hello there. Welcome to our last flip lesson of the 2016-17 school year. Today we're going to be talking about both the introduction to scientific notation homework I gave you previously and then the notes on describing large quantities with scientific notation. So I just wanted to make sure that first that you guys had this information correct. So you were supposed to look over this diagram previously. But just to remind yourselves that when we had laws of exponents, when we said that 10 to the negative first was equivalent to 1 over 10 to the first, if we were to take a look at this one right here, where it says 5 times 10 to the negative first, and when I rewrite that as now 5 times 1/10, or excuse me, 5 times 1/10, doesn't that make sense that that's going to end up giving us 5/10, which is what the answer is as a decimal. So what they're showing you here is that we have numbers that we write in our standard form. This is the standard way you would see a number. Then these numbers are all written in scientific notation, and they use powers of 10 to do that. And then they're just telling us what the exponents are. So if we come along down here, you were supposed to go through the examples, and just want to make sure that we have the right answers. A was true, B was false, C was true, and D was also false. So just take a minute to check those over, make sure that they all make sense to you. So then for number 2, they wanted you to order these numbers from least to greatest. So I have 2 3/400 times 10 to the second, 2 3/400 times 10 to the negative second, and then I also have 2 3/400 times 10 to the 0, because anything to the 0 power is equal to 1. So technically, that's the power of 10 that is being multiplied by that 2 3/400. So since you have 2 3/400 for all of these numbers, all you need to compare now is the actual exponents. So the smallest exponent would be the negative 2, so that's choice 2. Then the 0, so that would be choice 3. And then choice 1. Okay? Moving on there, this is the key concept. This is the definition of scientific notation, so we need to pay extra close attention to this. It says that some numbers are just so large or so small they are difficult to write because you'll have so many numerals in the number. They're telling us that we can use scientific notation to express such numbers so they are easy to write and compare. So they're telling you a number in scientific notation is written as the product of 2 factors. One of those numbers has to be greater than or equal to 1, but less than 10. So that's one of the factors. And then the other factor is the power of 10. This is the other factor. So again, they're giving us an example and showing us that the first factor, this is actually greater than or equal to 1 and less than 10. And the exponent over here, 10 to the 5th, the exponent is an integer, meaning it's not a decimal or fraction. So again, here's this vocabulary. This is the number 692,000 in standard form. If we were to write this in scientific notation, it would be equivalent to 6 and 9200 times 10 to the 5th. So then for example number 3, they wanted you to go through and actually circle the numbers that were written in scientific notation. And then for the numbers that you did not circle, they wanted you to say why. So I'm going to circle which of these numbers are actually written in scientific notation. Okay, so the reasoning why I did not circle the first one is that this number is greater than 10. It's actually greater than 9. The next one, the 4 2200ths, technically, yes, we could say times 10 to the 0, and that would make it equivalent, but in its current state, it's not written in scientific notation because it just has the regular standard number. This one, because it is 10, we only want one digit in front of the decimal. right now the decimal is located behind that 10, or that 0, so that makes that number bigger than 10. For the next one, this does not have a base of 10. It has a base of 2 being raised to the 10th power. That is not the definition of scientific notation. The definition of scientific notation says that it has to be multiplied by a power of 10. 2 to the 10th is not a power of 10. Powers of 10 are easy. They're 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000. Tells the exponent tells you how many zeros there are. The next two were written, and then this one, this number is less than 1, so that can't be scientific notation. And for the last one, it says which of the following numbers are not expressed in scientific notation. Not expressed, so make sure you read that carefully. It would be choice 2 because this number is greater than 10. Okay, so now we're going to go to the notes on scientific notation to describe large quantities. Oh, no, I'm sorry. Not yet. Still have another page. So this page, I went over this quickly in class, but just to talk about it again here, they're giving you some really large numbers to look at, 800,000 times 7 million, and they're asking us to use paper, pencil, or mental math to multiply this. So most people would say mental math, well, since I have all those zeros, I would just multiply 8 times 7 to get me 56, and then count up the total number of zeros and attach that onto the 56. So that's one way that you could do this. If you were to actually pick up your calculator and put 800,000 times 7 million in there, it won't fit in your calculator. There aren't enough digits to display all of those numbers. So what would happen is your calculator would end up probably writing it in scientific notation for you if you have a scientific calculator. So they're giving us an example of what a calculator would look like in scientific notation. So they're showing us here that it says most calculators do not have enough space to show that many digits, so they have special notation, which is scientific notation. We talked about this in class already, that the 5 6/10 e positive 12 is the same thing as the 5 6/10 times 10 to the 12th. So I said that I was going to show you some different calculators, so just give me a second for that. Sorry about that. I didn't have the microphone near me. So here's an example with 2 different calculators where I just typed in 2 really large numbers to multiply them by each other. And on this white calculator right here, they are actually showing you 4 times 10 to the 15th. So this calculator, it looks very similar to how we would actually write it in scientific notation. But if you look at this calculator on the right, it just says 5 6/10 and then this little 18. There's no E or the 10 there. So we need to be careful that if you have this type of calculator, that's what scientific notation looks like. So again, all I did was just take 8, multiply it by whatever's, and that's what I got as my answer. So that they're writing in scientific notation, they're just leaving off the times 10 part. Same thing with this Casio calculator. They're also left off the times the 10. And then if the Texas Instrument calculator is similar to the white one, where they do have it look like it in scientific notation. So just again, I wanted you to see. So I would just test that out with your own calculator, pick it up, throw in 2 really large numbers, and multiply them together. Okay, so back on the notes, just to give you what the correct answers would be. When you're looking at these 2 numbers that are being multiplied, right now the decimals are located right here. And in order to write our numbers in scientific notation, we want the decimals to end up with just 1 number in front of the decimal point. So that would mean that the decimal went 1, 2, 3, 4, 5, 6, 7 places. And on this one, the decimal would go 1, 2, 3, 4, 5, 6, 7, 8 places. So 7 places plus the 8 places will tell us that we're going to be multiplying by a power of 10 of the 15th. So your final answer becomes 5 times 2. And then how they have it shown on the left is with E positive 15, but how it would be written in scientific notation would be 5 2/10 times 10 to the 15th. So when you multiply 2 really big numbers, it would make sense that your exponent is positive. when you divide a number by a really big number, it's going to make sense that your exponent now is negative. It doesn't mean that your base value is negative. It just means that we're dealing with a number that's a lot less than 1. So if I have the place value here, if I move it over here one spot, that's 1 place value. And then if I went 1, 2, 3, 4, 5, 6, 7, 8, there's 8 place values here. I'm actually going to subtract these two, and so I get 5 2/10 e to the negative 7. This next one would be 5 2/10 e to the negative 10th, and then 5 2/10 e to the 17th. And then the last one, to write it in scientific notation, it would just be 7 7/10 times 10 to the negative 11. I wouldn't worry too much about this whole e business and being nervous about it. You just need to know how to use your calculator. So now we are going to go to the notes, and I apologize for talking so much, but we're going to go to the notes for today that I wanted to be able to get through today. And again, it's very similar to what we were just talking about. It says when you're working with large numbers in standard form, it is helpful to express them in scientific notation. We can compare the numbers a lot easier. So if you want to go from standard form to scientific notation, there are 2 methods to do this. Right now, I'm only going to focus on method 2. If you want to look through method 1, that's perfectly fine, but the way that most people do this is with method 2. Again, to write a number in scientific notation, it means that we need 2 numbers being multiplied by each other, where the first number is 1 or greater, but less than 10. So what they're doing is they're saying, we're going to take the decimal point and move it from behind the 0 to between the 3 and the 8. 1, 2, 3, 4, 5. So because I moved it 5 places to the left, I'm going to rewrite it as 3 84/100 times 10 to the 5th. Now the number's in scientific notation. Then if we want to go from scientific notation to standard form, there are 2 ways to do this as well. You could go 7 32/100 times 10 to the 6 and rewrite 10 to the 6 as actually a 1 with 6 zeros after it, and then multiply those out and get 7,320,000. Or, again, the method that I'm going to be focusing on here is method 2, where you take your decimal point and you move it 1, 2, 3, 4, 5, 6 places to the right, because when you multiply by a number, it makes sense that the number would get bigger most of the time. And then you insert zeros into the loops to get 7,320,000. So, question number 1 says that 1 astronomical unit, an AU, is the average distance between the Earth and the Sun. So it is approximately 93 million miles. So they want us to express this distance in scientific notation. So the first thing we need to do is even be able to write 93 million miles in standard form. So that's 93 and then million. So the 3 is in the millions place, and it's 93 and our 6 zeros. So you take your decimal point, put it behind the 0, and go 1, 2, 3, 4, 5, 6, 7. Because again, you only want 1 number in front of the decimal point, and so your answer is 9 3/10 times 10 to the 7th. Go ahead, try number 2. So again, decimal point 1, 2, 3, 4, 5. So it's 1 86/100 times 10 to the 5th. So really quickly, I would be able to compare 1 and 2, example 1 and 2. I know that example 1 would have to be bigger because it's with 10 to the 7th. So that number is definitely going to be larger than example number 2. On to the back. They are saying that the estimated age of the universe is 1 37 hundredths. 1 37 hundredths times 10 to the 10th. And they want us to express this age in standard form. So, how we're going to do this is, since I know I'm multiplying by 10 to the 10th, which is a really big number, I'm going to write the 1 37 hundredths, and then you need to be really careful when you count and draw your loops here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where your decimal ends up right here. I add in the zeros. Notice I'm not adding in 10 zeros, I'm just filling in the place values. So I actually added in 1, 2, 3, 4, 5, 6, 7, 8 zeros. Do not leave your answer with all the loops in that. Please rewrite it add your zero or commas in to make it easier to check your answers. So we have 13,700,000,000. Okay, go on and try number 4. So start with a 2 and 4 tenths. Go 1, 2, 3, 4, 5. Fill in their loops with the zeros. It becomes 240,000. So question number 5 is just saying that they want us to describe at least one large measurement unrelated to astronomy that you might want to write in scientific notation rather than in standard form. Some previous examples from previous years, people said the population of the world. And even that, when we say the population of the world, we say 7 billion, and we actually read it as 7 billion. Most of the time, that's a kind of a version of scientific notation, but not quite. Some people also said the U.S. budget, or our deficit, could also be written in scientific notation. So there's lots of other ways to do that. So question number 6 says that the table shows numbers of bacteria in 4 colonies in a microbiology lab. To complete the table, estimate each number in scientific notation using a single digit for the first factor. Then determine whether each statement is true or false. So what they first need to do is rewrite these 4 numbers in scientific notation. So why don't you go ahead and do that. Make sure, though, that you estimate. So this first one would be actually 8, and then all of these other zeros after it. So just be careful of that. All right, so check over your answers and make any changes if necessary. So they're just asking us to estimate by rounding to the nearest, I guess, whole million or billion or 10 million. So choice A says that colony A has about 40 times as many bacteria as colony B. So instead of comparing our numbers in standard form, we're going to compare the numbers in scientific notation. So if we look at the first factor in each of those, we have an 8 and a 2. So if I'm thinking about 40 times, I'm thinking the opposite is division. So 8 divided by 2 is 4, but since their powers of 10 also differ by 1, they differ by 1 power of 10. 1 power of 10 is 10 to the first, which so we really have to then also, since this says multiply, 4 times 10, which does give us 40. So this is actually true. For B, it says colony C has about 30 times as many bacteria as colony B. So if I compare 6 times 10 to the 6, all divided by 2 times 10 to the 6, 6 divided by 2 ends up equaling 3, and doesn't 10 to the 6 divided by 10 to the 6 cancel out? So that leaves me with just 3. So it's not true that it's 30 times, it's only 3 times. And then colony, or the last one, says that colony B has about 5 times as many bacteria as colony D. So they're saying colony B is larger than colony D, and colony B is 2 times 10 to the 6 divided by 4 times 10 to the 5th. And at first you might be saying, well, doesn't it look like B is larger than D? But be careful, or so that D, you might think that D is larger than B because the 4 is larger than the 2, but when you're looking at your exponents, the 6 there actually ends up making it be bigger. So we have 2/4, which reduces down to 1/2, and 10 to the 6 divided by 10 to the 5th becomes 10 to the 1st. So we have 1/2 times 10 to the 1st, so we're looking at half of 10, which is actually equal to 5. So this is also going to be true. So we can apply our laws of exponents here to help us solve these out. So if you could go on and try number 7. Okay, so again, I'm comparing colony A to B. I fill in what they are in scientific notation. I then simplify and multiply to get that it is 20 times. Okay, so have a great weekend, and we will see you guys on Monday.